Okay, we're going to go over simplifying radicals. This next unit is going to be all about radicals. We'll start with simplifying. We'll go to adding and subtracting later on. And then we'll go to solving radical equations. But simplifying radicals, basically what this is we take the example we have here, radical 18, which we could also refer to as the square root of 18. In the past, what we've done is we've punched this into a calculator and we got a decimal, which would be 4 point something. But what we're going to do now, we're not going to be using any calculators in this unit because they're not needed. What we're going to do now is we're going to simplify these radicals by basically pulling out all the square roots that we know in it. So what we're going to be doing is we're going to be looking at, in this case, the number 18. I have to look at what perfect square factors are in the number 18. So over to the right here, we see a few perfect square factors that we can pull out. We can look at, does 4 go in 18? Does 9 go in 18? Does 16, 25, 36, and so on and so forth. We can look at all these perfect square factors we know, and we can look at which one of those are in 18. So I know 18, okay, radical 18 is what this is going to be referred to as. I could say radical 9 times radical 2 gets me radical 18. Basically what I've done here is I've pulled out this perfect square factor right here. Now what I do is I find the square root of 9, which is 3. I look at my other one now, radical 2. Do I have any perfect square factors, other than 1 obviously, that are a factor of 2? And there are none. So that radical 2 remains. Therefore, my answer is 3 radical 2, which could also be referred to as 3 times radical 2. So radical 18, rather than punching it in a calculator now, we're going to see that as 3 radical 2. So I'll give you another example here that's a little bit bigger that we got to do a little bit more digging with. Alright, so this one right here, square root of 192, or radical 192. I have to look, do I have any perfect square factors that go into this? So usually what I do is I usually start, if it's a big number like this, I say, can 4 go into it? And I know 4 can go into this one, so I can basically say radical 4 times, in this case it's going to be radical 48, because 48 times 4 is 192. And people are probably wondering, well, how the heck do I figure that out? If you can't figure out right away what goes into it, start with a lower number, start with a 4. See if 4 can be divided into 192 evenly, and it can 48 times. So when I look at this, radical 4 I know is going to be 2. This radical 48, I look, do I have any perfect square factors in there? And in this case, I myself know that this could be breaking into radical 16 times radical 3, because 16 times 3 I know is 48. If you didn't know that off the top of your head, you probably would have said, well, 4 goes into 48. You could have done radical 4 times radical 12. Then you would have had to simplify the radical 12 because you could pull another 4 out of that. So in this case here, square root of 16 I know is 4. Now I have radical 3. I have nothing, no perfect square factors I can pull out of radical 3. So that radical 3 stays what it is. So what I like to do is, once you find the square root of a number, like I did here with the 4 and with the 16, I circle what that square root is. Once you find the square root of something, it is now outside the radical. Okay? So in this case here, I have 2 and 4, which I can multiply those together. So 2 times 4, and the reason why we're multiplying is because, remember, we're pulling factors out. So 2 times 4 is going to get me 8, and then I have this radical 3. So if by chance, let's say for example in this problem, I did things somewhat differently and I ended up coming out where I had 2 radicals at the end. Say I had radical 3 and then let's say I had a radical 2 at the end as well. What I would do is I would take this radical 2, multiply by the radical 3, so I would have that radical 6 in my final answer. So basically, the thing to remember here is you're multiplying every single one of these because they are factors. So once you pull a perfect square out, find the square root of it. Once you find the square root of it, it is now outside the radical sign, as we have right here with the 2 and the 4. So I multiply the 2 times 4 to get me 8, and I just pulled my radical 3 right in there. So now I'm going to give you an example that has variables in it. Alright, so this one, the best thing to do is split out your terms. So what I have here is I could say I have radical 12, I have radical x squared, and I have radical y to the third. Okay, I'm going to tackle these separately, but I'm going to put it all together like I did with the previous problem. And the reason why I can break this out into 3 separate radicals is because what's inside the original equation, our radical there, says 12 times x to the second times y to the third, which is basically what all this says right here. Okay, so radical 12, I know that I have radical 4 and radical 3 gets me to radical 12. Now the thing to remember, only pull out perfect square factors. So I would not do radical 6 times radical 2 because 6 and 2 are not perfect squares. So only pull out perfect square factors. So I know square root of 4 is 2. Can't do anything with radical 3. So these 2 that I circled are going to go in my final answer. Now we look at the variables. In order to be, and you may want to write this down, in order to be a perfect square, it has to have an even number exponent. So in this case here, x squared, that's a perfect square because its exponent of 2 is an even number. And the reason why is the way that I get x squared is x times x. So the square root of x squared, I can say, is x. In this case right here, I have the square root of y to the third. So it has an exponent of 3, which is not a perfect square. So what I have to do, though, is I have to pull the perfect square factors out. So I look at what is the closest even number that is below 3, which we know is 2. So I can break this one out to the square root of y squared times the square root of y, or y to the first. Okay, because y squared times y is y to the third. So basically what I've done is I pulled a perfect square out of this. That perfect square, square root of y squared, is just y. And then now over here what I have is I have my square root of y, which I know that the exponent on that y is a 1. So it is not a perfect square. So it's going to remain as it is. So that's going to be my answer as well. So now, to piece this together for my answer, what I'm going to do is this. I'm going to look and I'm going to say, what do I have without a radical? I have this 2, this x, and this y. So if I multiply those 3 together, I'm going to get 2xy. That's outside my radical. What's inside the radical is going to be this guy right here and this guy right here. So I'm going to multiply those together. 3 times y is 3y, and this right here is my final answer. So what I'm going to do now is I'm going to go over one more problem that has only variables in it, so you can see one more example of how we pull those out. Alright, so in this one right here, okay, I'm going to break this thing down into square root of x to the 5th and the square root of y to the 6th. So I have 2 separate that I'm working with here. Now, from what I said with the last problem, I know that in order to be a perfect square, the exponent has to be an even number. So when I look at x to the 5th, it's not an even number. So what I have to do is I have to break this into a perfect square, and then with these you will always have, if it's an odd number exponent, you're always only going to have one of that variable left over. So in this case, just that x. But now, if I take one x away from x to the 5th, that's going to leave me with x to the 4th, which is a perfect square because it has an even exponent. Now, the square root of x to the 4th is x to the second. All I do to find the square root of it is cut the exponent in half. So x to the second is going to be in my answer. This will be in my answer as well because it has an odd number exponent, so I can't put it, can't do any more simplifying with that. Y to the sixth, okay? That exponent of 6 is an even number, so I know this is a perfect square. So what I do to find the square root, okay, I'm just going to cut that exponent in half, so y to the third, because I know that y to the third times y to the third, keep the base, add the exponent, gets me y to the sixth, which is in my radical. So now I have to piece all this together. Okay, so with my final answer, what my final answer is going to be, again, first thing I want to do, look at what's outside the radical, which are these two. So I'm going to say x squared y to the third, and then what's inside the radical is just this right here, so that's going to remain in the radical as radical x. So that will be my final answer. So give the homework sheet a try. If you got any questions, feel free to email me.